squared and x to the fourth. So x squared is actually a little bit narrower than x to the fourth. X to the fourth is going to sort of belly out and then come down. It's actually more like the Miami U University shape. They intersect at 0, 0. And I think you'll start to notice that these graphs also intersect at 1, 1. I can show you the algebra by setting them equal to one another. X to the fourth equals x squared. Bring over the x squared. That gives me x to the fourth. Minus x squared equals 0. Factor out x squared. That gives me x squared times x squared minus 1 equals 0. That is going to be 0 when I let x squared equal 0. And that's going to give me two answers. X squared equals 1. X equals plus or minus 1. And notice they also intersect over here at negative 1, 1. I'm going to use different limits of integration. I'm going to use it from 0 to 1. But because it's symmetrical, and I have this area and this area, I'm going to put a 2 out in front of my integral. And that makes this legal. You could have done from negative 1 to 1, especially if you're using a calculator. It'll generate the answer from negative 1 to 1 just as quickly as it will from 0 to 1 times 2. It doesn't matter. The top graph, when the area of shading, is going to be x squared minus the bottom graph, which is x to the fourth. I'm going to do it by hand. It's not a difficult integral. So it's going to be the out front, the 2, times x cubed over 3 minus x to the fifth over 5. Leibniz notation from 0 to 1. I'm going to set up my big brackets because I have a 2 out in front. That's going to be a template of something cubed over 3 minus something to the fifth over 5 minus, I'm going to use parentheses inside a bracket. Another template, x cubed over 3 minus something to the fifth over 5. Close that because I have to distribute the negative across. Now I'm going to plug in my limits of integration, 0 in the back and 1 up front. So I put the 1 in up front and the 0 in the back. And notice this is nice, this all goes to 0. So this is going to actually give me 2 times 1/3 minus 1/5. And I'm going to use my algebra 2 method to add those fractions. That's going to be 15 on the bottom, 5, 3, so that's going to give me 2/15. But don't forget I have to multiply, I have to multiply that by 2. So that's going to give me 2 times 2 over 15. And my final answer should be 4 over 15. Okay, for 17 I want to graph cosine x and y equals x squared minus 1. So I kind of know cosine x starts up high and then goes through, I guess at pi over 2. And then bottoms out at pi, and then it keeps going at 3 pi over 2, and at 2 pi it goes full cycle. And then it goes back the opposite way. It keeps going like that. That's cosine x. And x squared minus 1, it's going to go up 1 over 1, up 1 over 1, and you get this type of graph, a parabola. And the important points that I want to find to set up the area of the shaded region is the top, the bottom, and the integral. So I could do from this spot here to this spot here, but I noticed that they're both even functions, and it's symmetric about the y-axis. So I'm instantly going to throw a 2 out front, and then from 0 to whatever this intersection is over here. Okay? So it's going to start at 0 and go up to whatever that is. And I don't know what that is yet. I have to figure it out. And I think I'm going to have to go to my calculator and graph this. So I have it typed in. I'm going to hit the graph, and I already had a graph. You know, my picture's not as good as theirs. Maybe theirs is a little off. Now I have to find out where they intersect right there. Right where they intersect, that's what I'm looking for. So I'm going to hit second calc. And I'm going to go down to intersect, which is number 5. And now I'm going to go a little close and hit enter. And then it jumps down below it. I hit enter again. I don't want to guess. I want to know exactly what it is. And it tells me the intersection is 1.765019. 1.765019. Now I have to determine which one's on the top and which one's on the bottom. So this is the top graph for my shaded region. This is the bottom graph. So the top graph is the cosine x minus the bottom graph, which is going to be the x squared minus 1. So I can type that in, or I can just go to my calculator, since I already have that entered into my y1. And notice, in this case, my y1 is on top, and my y2 is on bottom. So I'm going to let the calculator figure out this integral for me. I'm going to get out of the graphing mode, and now I'm going to go 2, because I have this 2 up front, math 9, because I want to do the integral, from 0 to 1.765019. And here it comes, of y1 minus y2. So I'm going to hit alpha calc, and there's my y1, minus alpha calc, and number 2 is my y2. Now, I don't even have to worry about distributing. With respect to the x-axis, enter, and there's my answer. I'm messing around with the zoom in case that's my graph. See, I can't get it to look a little bit better. I'm actually going to go to window, and I noticed from my graph that I don't need it that far to the left, negative 10, that far to the right, positive 10, that high, 10, and that low, negative 10. So what I want to do is I'm going to narrow down the window to negative 2, positive 2, negative 2, positive 2, and let's see what that looks like. Just a tighter graph, so I can see where I'm going to intersect and whatnot. Now again, due to symmetry, I'm going to do it from 0 to some number. And I'm not supposed to know what that number is yet. And that's going to be this spot right here. This spot on the actual paper graph. So I'm going to hit second calc 5 for intersect. Enter, enter, enter. And be careful when you write down your limits of integration. Otherwise, it'll give you a totally bogus answer. And this limit of integration is 1.1765019. If you even mess up a little bit, it's going to be way off. 1.1 7,65019. Now I'm going to go to my graph. Now I'm going to go to my calculator, normal mode, and I'm going to hit math 9, because I want to find the integral. And my lower limit is 0. My upper limit, are you ready for this, is 1.1765019. And this is a little trick also. I don't want to have to type in that whole equation, so I'm going to go back to my graph and hit alpha calc, and I'm going to choose y1, which is my upper graph, my top graph, minus alpha calc 2, y2, with respect to x. Enter. Now, I have to multiply that by 2, because I'm only doing half the graph. Remember, it's symmetric. It's both even functions are symmetric about the y-axis. So I'm going to take that answer and multiply it by 2. And there's my final answer. 3.114. I want to evaluate the velocity at 2. So there's the particle's motion is mapped by that equation, so I want to take the derivative of that to get my velocity function. So I just have it up here chilling. So velocity is going to equal negative 3t squared plus 14t minus 14, and the derivative of 8 is 0. So to find the velocity after 2 seconds, I just plug in a 2 to this equation. And then evaluate it. And I think that's going to give me 4 times negative 3 is negative 12 plus 28 minus 14. Since this is like a calculator active portion of the test, I'm going to enter that into the calculator. Negative 12 plus 28 minus 14, lo and behold, equals 2. Maybe I shouldn't have done it, but I did. That's going to be meters per second, because that's the velocity. Let's do acceleration. That's going to be meters per second squared, if it's acceleration. So let's evaluate this. I'm going to take the derivative of the velocity, and my acceleration function is going to equal negative 6t plus 14. Just plug in a 2 wherever there's a t. That's going to give me 14 minus 12, which again is 2. This time it's meters per second. When is the particle at rest? So I'm going to take the velocity and set it equal to 0. So I'm going to graph the velocity function. Negative 3t squared, I know it's an x, plus 14x minus 14. And I'm going to graph that. Really can't see the graph because I'm back in the old window. So let me get that to fit. I'm going to zoom. I see it's a little to the right. Maybe I'll do a window and go from negative 2 to 10. Y min, Y max, maybe to 8, and see what I get. Pretty good. What I want to do is find out where it intersects there and there. I want to know when it's at rest. When is the particle, excuse me, at rest? I want to find out where it's 0. So I'm going to hit second calc and go to 0. And I want to get it to the left. And let me see here. Bring it into my screen. Oh, left bound is at 5. I want to get it over there to like between 2 and 1. There it is. Left bound, enter. Right bound, enter, enter. So 1.451 is one of the spots. 1.451 seconds. It's at rest. Now I want to find the other time it's at rest. So I hit second calc 0. And now I want to get over to this side. Left bound it, enter. Get it to the other side, right bound it, enter, enter again. And that's at 3.215. 3.215 seconds also. Find the distance traveled from 0 to 2. Distance is different than displacement. With displacement, it would be the integral from 0 to 2. This would be displacement of the velocity function. Negative 3t squared plus 14t minus 14 dt. That would be displacement. But distance is the absolute value of that. And again, that's just a calculator key in. So let's go ahead and type that. Get in normal calculator mode. And now I'm going to type in math 9. Now, a shortcut to get to the absolute value button would be alpha window. Alpha window. And that gives me the absolute. But I want to do my limits of integration first. 0 to 2. Now I'm going to do my alpha window. And absolute value is the first thing up there. I'll type it in like it looks. Negative 3t squared plus 14t minus 14 with respect to t. And the total distance traveled is 9.262.